Dang it, it's not appearing. Aha, there we go. Hello everybody, once again, welcome to Alex Does LeetCode. Technical problems are tricky. We all learn from our technical problems but this is the channel where we get together and we learn how to program together live on stream. Once again, if I'm hoping that some brave viewer at some point will volunteer to come code with me. So not just watch me code, but code alongside me. Using collaborative coding platform, we're probably going to use Replit, and we will see, and that would ultimately be the best way to learn. Today's problem is subsequence. So let me introduce the problem really quick. So it goes like this: given two strings s and t, returns true if s is a subsequence of t, or false otherwise. A subsequence of string is defined as a new string that is formed by deleting some or none of the characters without disturbing the relative positions of the remaining characters. When I see a wall of text like this, I like to go to examples, right? So we know that essentially we want to see if S contains T, or rather T contains S, but we want to be very precise about what contains means. So we scroll down and look at examples. For instance, we have A, H, B, G, C, D, C. If we remove H, we remove G, and D, we get A, B, C. So that is a subsequence, and that comes out to true. If S equals AXC and T equals AHBGC, there's no X here. So very clearly, it's not true. That is not the only time missing characters. It's not the only time when one string is not the subsequence of another. For instance, in this example, we have A, B, C, D, E. This example right here. ACE. Let's see. ACE is ACE, right? You delete D and you delete B. So ACE is going to be a valid subsequence. But, interestingly enough, AEC is not. Because even though you have A, E, and C as characters, they are not in the right order for you to get to this subsequence just by deleting characters. So AEC is not a subsequence of A, B, C, D, E. Right? AEC is not a subsequence. So the ordering matters. So let's think a little bit about what we want to do here. Well, essentially, what we want to do is we want to start with the sequence T, and we have a given sequence S. And essentially, you want to do some matching, right? You want to say this A goes to here, this B goes to here, this C goes to here, and so on and so forth. We want to do some matching. So that's exactly what we're gonna do. We're gonna think about it as two lines of people, or two the lines of numbers or letters, and whenever we have a match, we sort of take that match and we move forward. And when we have no match, for instance, if we have let's say we have AEC, ACE, we'll go to A first. A is a match. B, nope, it's not C. C is a match, and D, nope. And then we go to E, and E is a match. So that's our basic strategy for what we want to do. Alright, so we're going to iterate over the two arrays at the same time. And interestingly enough, the truth is we're only iterating over one array. And when we get to the end of S, we're done with the program. We're done with the program. If we get to the end of S, we're done with our program. If we, somewhere halfway through, before we got to the end of S, we see something like this. We reach a place where we get stuck. A matches E, nope. E, nope. E, Nope. E, yes, matches. C, well, we're done. If we get stuck, then we return false. So that's going to be our strategy here. So let's do a for loop. Let's do a for loop. Or actually, I have a better idea. Let's do a while loop. A for loop will also work, but I like a while loop because the while loop, to me, in my mind, is closer to the mental model of what we're trying to do. We're going to have an index. We're going to have index of A, index of B, also 0. Okay? And the idea is while index of A is smaller than length of S. I should call this index of S and index of T. Index of S is smaller than the length of S. It's smaller than the length of S. What we're going to do is we're going to do if S, index of S, equals to T, index of T. If they match, we're going to advance both indices by 1. Else, if they don't match, then we're just going to advance. If they don't match, else. Oh, oops. Else, if they don't match, we'll just advance T. We're gonna, like, for instance, A and A matches, C and B does not match. So we sort of delete B and we go to the next one and we check if it matches. So if it doesn't match, we're only advancing index T and we keep C the where it was. We're gonna keep C where it was before. We're gonna keep the index S where it was before. So, and now here C and C is a match again, so this means that we get to advance both. E and D not a match, delete, and we advance index T. So that's the strategy that we're gonna use. That's what strategy we're gonna use. We're gonna have 2 pointers, 2 indexes moving around. Now, if index T, now if we got to the end, is larger or equal to length of T, if we get to the end of T, then what that says is you can return false. We got to the end of T, we have nothing left in T. Well, this is clearly not working out. Okay, and if index S, however, gets to the end first, and we exit this while loop, we return true. Okay, there is some edge cases. So when you're dealing with problems like this, there's always going to be these edge cases. Now, there is an edge case I immediately think of, which is what if index T starts off, what if either of them starts off as empty string, right? So we start with index S equals 0, index T equals 0. We're comparing the first character right away. If either of them is in empty string, something it's going to give. If S is the empty string, if T is empty string, well, return false. If S is empty string, return true. Because, look, if S is empty string, S equals nothing, and T equals to A, B, C, whatever, you can always get from T to S by deleting everything. So when S is the empty string, whatever T is, we're good to go. If S is not the empty string, and T is the empty string, well, that sucks. That means that it is clearly not a subsequence. And this is like A, B, C, whatever. So we have these. Note that these two lines, these two if conditions, we flip it around, this will not work. We will not work. We have to be careful about when both of these are true. When both S and T are empty strings, then what do we want to return? If both of them are empty strings, then, well, is it a subsequence? It is a subsequence because it's the same sequence. So return true. Okay, I'm pretty sure this should work. Oh, I was wrong. Output true, AXE. Oh, yes. This. So I need to check that T has not reached the end. T has not reached the end. Yeah, I need to check that this is true. So even for this case, because I'm advancing T, oh, interesting. Wow, I was very confident. This is shocking to me. So AHAXC. So after A, we should keep going. While index S is smaller than length of S, we should theoretically keep going. Interesting. I'm not sure why this is the case. Well, let's stick it into a Python tutor. Or maybe this time, let's try something different. Let's try using Replit. Let's try using Replit. Let's try using Replit. And we're gonna say... what are the test cases? Interesting. I'm quite surprised it didn't work. I'm shocked even. Solution S dot is subsequence AXC comma AHBGDC. Okay. Let's see what happens if I run this. Okay, we need to put a breakpoint. Let's put a breakpoint somewhere. Let's try this. Oh, I see. If length of S equals true. I'm sorry. If length of F equals 0. So length of S and T start off as positive integers. So to Python, length of S equals true. Like this is a valid condition. Just, yeah. Okay, cool. We're good to go. 16.64. I'm not sure why there's so much variability. Well, it's 82%. Let's not run again. Oh, it's gone down. That breaks my heart. Okay, so that's it for its subsequence. We do have time, so let's try another easy problem. I've not actually prepared one, but let me take a look at what problems are available, and we'll just pick one. But we gotta pick an easy one. So probably the next time we do this, we will pick a medium problem. Let's see, you can find one with a funky name. Two strings are close. An easy one. Dota 2 Senate. Wow, what's this? Keep. Guess higher or lower number. Nah. M Fibonacci problem. Minimum cost. Counting bits. Single number. Let's just pick one of the easy ones. Greatest common divisor of strings. That sounds interesting. Greatest common divisor of strings. Let's see what we got here. Okay, this is supposed to be an easy problem. Greatest common divisor of strings. For two strings s and t, we say s divides t if and only if s equals t plus ... plus t. Oh, okay. So if s is t repeated a bunch of times, this is interesting. This is not that easy. This is not as easy as the last one. Let's look at some examples. Let's say string 1 is ABC, ABC. String 2 is ABC. Then the greatest common denominator, the greatest common divisor, is going to be ABC. Okay. Okay. So likewise, ABA, BAB, ABAB. Wait, why is it AB? AB, AB, AB. Oh, I see. AB, AB, AB. There are three ABs. And string 2 is AB. Okay. So we want to find the greatest common denominator between two strings. Let me think about it a little bit. So one thing that immediately jumps to mind is, first, I can find the greatest factor of a string. Right? If it says t divides s, only if s equals to t. So let's find the biggest t for each s. Can we do that? So the biggest t for string 1, well, it's going to be the whole thing. Okay, so in this case, for instance, this case interesting because it's ABAB. So we match ABAB at the start. String 1 and string 2 match. And then this thing we need to know repeats itself. Okay, so I have an idea. I have like a weird idea. Let me think about this weird idea a little. First, we take the length of the two strings. Is the GCD of two strings just... Let's first take the length of two strings, right? If let's say one string is at 5 and 3, the GCD is 1. Then we look at the first character and we see if that repeats itself. If it is, then it's GCD. If not, it's not. Okay, let me think whether there is a time with where this rule breaks. So let's think about two slightly larger numbers. Let's say 24 and 64. Okay, the GCD of these two numbers is 8. Okay, so now we have to check if the first 8 characters repeat themselves. If the first 8 characters repeat themselves, then yes. If the 8 characters don't repeat themselves, then it's false. I'm tempted to go with this line. I mean, again, this is something I want to mention. So if you're doing a programming problem, like a competitive programming or whatever, one thing you could do, like a contest, is just write it and test on the test cases to see how it goes. Okay, let me think for but if you're writing production code, if you're doing real programming, right? Then there are no test cases given to you. You have to figure out by yourself if this is the right strategy, if it's going to produce the right answer. So let me think about it a little bit more. I don't want to cheat and rely on the test cases. Is it possible? Let's say in this case, right? Is it possible for the first 8 characters to not repeat, but the first 4 characters repeat? No, that's not possible, right? If, for instance, 24 is A, B, C, D, E, F, G, A, B, I clearly don't know how to spell E, F, G, H. Yep. Okay. So let's say we have something like this. Is it possible for this not to repeat itself, but a smaller one repeats itself? That's not possible, right? If the first 8 characters do not repeat themselves, then the first 4 characters are not going to repeat themselves. So that's clear. So if the first 8 characters do not repeat themselves, the first 4 characters do not repeat themselves. Now, if the first 3 characters, is it possible? I don't think it's possible. That's my gut feeling. Okay? That's my gut feeling. So if I'm writing production code, I might think about it a little bit more. Here, I am just going to try it out and see what happens. So step 1, we have to find a way. I wonder if there is a math function that gives me the math.gcd. Okay, we're going to do math.gcd, import math. So we don't have to calculate the GCD ourselves. Length math.gcd of length string 1, length string 2, divisor length. Okay. So we're going to check if string 1 is just string 2 repeated a bunch of times. So divisor length is the GCD here. To check if string 1 is just the first, divisor length characters repeated a bunch of times. Well, we do this. Length string 1 divided by divisor length. Okay. We take the first n characters of string 1. String 1. Oh, actually, we have to check 3 things. First thing, we have to check if string 1 divisor length 0 to divisor length. So this is string slicing, not equals to string 2 divisor length. Then return false. And then we establish that the first divisor length characters of string 1 and string 2. So for instance here, the first 8 characters of string 1 and string 2 are identical. So once we've established that, we go on to check if this like word, this word repeats itself. If not equals to divisor times, so divisor is a string. We're doing string arithmetic here. Length of string 1 divided by divisor length. So in this example, divisor length will be 8. Okay, so in this example, divisor length equals 8. We're gonna check divisor will be equals to the first 8 characters of string 1. We want to check if that is equal to the first 8 characters of string 2. If it's not, then we're done. If it is, we want to check if this first 8 characters is being repeated many times. And we do the same for here. And if all the checks pass, then return true. I think this should work. Let's try it out. Can't multiply by non-sequence. Oh, okay. So this is a quirk with Python. So basically what this says is that string 1 divided by divisor length will give you a floating point back. We know for a fact that divisor length is a factor of string 1. It divides evenly. It's going to be a whole number. So we use whole number division. Alright, let's see where we get here. Oh, they're all wrong. Oh, we're supposed to return not true or false. But we're supposed to return divisor. Okay, let's run it again. Again, read the question carefully. The way it works is that in production code, there are no easy test cases for you. You have to be very careful about what you're supposed to output. Although, to be fair, in production code, if you mess up like that, it will be fairly obvious. Okay, so we're done. This is not the fastest, but this could be, it's small enough. 43 milliseconds is small enough that this, beats 69%. Well, who knows, right? It might be a function of my computer. It might be a function of randomness. Yeah, it's sort of random. Okay, cool. So that's it for today. Thank you very much for tuning in. Next time we're probably going to do a medium question of medium difficulty. I am going to stay on stream, and I am going to keep hunting my white whale. As you guys probably know from last time, I was trying to write quicksort that works on the linked list, and it turned out to be harder than I thought it would be. So I am going to